Okay, Ginger.
All right, welcome to the WERC Environmental Design Contest video conference. We're glad you're joining us. I'm Ginger Scarbrough, the program manager, and we have Dr. Dan Gulino and Dr. Mike Hightower here to give you an overview about the contest. So we're not going to cover questions about specific tasks that you might be choosing to work on, but instead how you will, considerations you need to make as you're preparing.
So let's see, I'm Mike Hightower. We're going to kind of do a tag team for you guys today. So I'm going to start off with some background on the design contest. Some of you are looking at this for the first time. We have a lot of teams that come back year after year, and so they get experience from those that have been the year before. But for some of you, it's maybe been 5 years or 3 years since you've got a team. You probably don't have the background on how the contest is run. And so we're going to go over that for you so that you can kind of get a feel for the approach, the process. And what we oftentimes see is that you'll read the design contest requirements, you'll see the instructions, and you won't know how to actually apply those. And so when it talks about providing information that's in the paper, what does that mean? So we're going to talk a little bit about that. When it says, here's what we want to see on the poster, you probably haven't been to the contest before and you don't know what that means. So we're just going to spend a little bit of time to allow you to kind of come up to speed on the requirements of the contest, why it's done the way it is, and how you can optimize your research activities at your schools, and then how you can come to the contest here in Las Cruces and do well. So with that, let me just go to the first view graph. Here we go. So I'm just going to give a short overview of what the contest is and what it isn't, because a lot of students have different opinions and views, and when they get here they go, oh, I didn't know that. So the first bullet point that I have there is that this is a environmental engineering contest, not a science fair project. So we're going to run this as it mimics an engineering or a science project process. I helped WERC set this up 30 years ago, which tells you how old I am, but the fact is
your
that,
hair tells us that.
Yeah, what we were trying to do was to develop a process that was similar to what you'll see in the real world as either scientists, environmental scientists, or engineers in your profession. And that is that they often go out for a request for proposal, an RFP as we call it, for a science challenge or an engineering challenge. And we've actually asked the people who are developing these projects and tasks for us to write that task up as an RFP. So it asks you to review the literature, come up with a design, discuss that design, and present it at the WERC Design Contest. And that's exactly what we see in most of these RFP, request for proposal processes, is that a task statement is published and a solicitation for either a science or engineering services to solve a particular problem. And this year we have 5 or 6 problems that you guys are each looking at. An RFP requests oftentimes a proposal. And so your paper will be kind of a proposal that says, this is what we evaluated, this is what we studied, we think this, we came to this conclusion that this technology is the best solution. So, and then they're going to want to know what that solution is, and then they would expect to see in that paper proposal your performance, your test data, the evaluations that you did, what you think the costs are going to be of that project, what are some of the environmental and waste issues, the public acceptance issues of your solution, and a schedule. Can you do it in 3 months, 10 months, 15 years? So that's what the typical RFP process asks for. So in our design contest, we're actually asking for very similar things, and I've underlined there in that bullet some of the things that you will see written up in the task proposal and request for papers. The paper says make sure that you present your solution, your performance, your test data, your costs, address environmental waste issues, public acceptance issues, and schedule. And so I'm just suggesting that what I've outlined here is exactly the kinds of things that the judges have criteria for. So when it says, please provide information on these, we have judging criteria. So you want to make sure that you address those. If this were just a science fair project, we would be only interested in what's the science, what your test results are, not necessarily the costs, the schedule, public acceptance, and environmental issues like waste management, et cetera. So this is, as I say, closer to a science and engineering approach rather than a science fair construct, if you will. Then in the real world, if you write a nice paper and the company says, oh yeah, this is great, they'll ask you to come in and give a presentation and present your results. And then if the results that you present really look good, they'll ask you to do a pilot study or a bench scale study. And if all of that works out well, then you'll win the proposal. So what we're doing then is, after you submit the paper, we're also asking you to actually come and present your results to a technical review committee. And in this case, the judges are selected from industry and a broad spectrum of skills that have capability in cost analysis, environmental issues, public outreach, etc. So they actually act as that technical review committee to review your proposal and your presentation. Also at the same time, then after the presentation, when you're here, you'll be asked to set up your bench scale process and operate it for the judges while you're here. And that kind of simulates this request for a pilot scale or a bench scale system that you generally get with the RFP process in the real world. So we're asking you to be able to treat some materials here at NMSU and show the judges that your process works and how you kind of developed your process. At the same time, we're asking you to have a poster that oftentimes is used along with your presentations through public forums, where you can show the public the benefits of your technology, your approach, your costs, and your schedule. It's very common in the technical arena in the real world to have poster sessions and to do poster presentations. And so we wanted to give you guys a chance to see how you put those together, how you manage those, and bring those to present to a technical committee. But I do want to mention that in the requirements of the projects, always read what's required to be included in the paper, which I've kind of underlined there, and then what's required in the presentation, And oftentimes they're looking for exactly the same things. They would like to see an overview presentation on your solution, what you looked at, your test data, your cost analysis, etc. So when it asks to provide information that's in the paper, those are the things they're asking for. So if you just provide your test results and that's it, you're not going to get scored very highly. So just remember that they're going to be asking for these kinds of elements, both in the paper, in the presentation, and to be included on your poster. And if you do that, you're going to score pretty highly. And that's what we're trying to do, is allow you to understand what the judges are looking for, so that it's not totally new to you, and can manage your time and your effort to be able to collect all this information and to make the best showing that you can when you come to New Mexico State. And so then I underlined at the bottom on the very last bullet, you'll win the contract in the real world based upon your cost, your performance, your schedule, your waste minimization, public acceptance. So don't forget that these are the major things that the technical review committee is going to be looking for. And so those are the kinds of things that you have to carry through in your presentation, your paper, and your poster to make sure that those are covered. So that's a background. The reason that this is important to us is we see a lot of times teams come in first time, they get overwhelmed. They think that they ought to focus on their data because that's what they do in all their classes, is they always want to do the analysis. But as a environmental engineering and design contest, we've got to look at a broad spectrum of issues. The science is important, but also the performance, the cost, environmental waste management, public acceptance are just as important to actually win an award in the real world and to win an award here. So don't underestimate that. You need to look at all of these issues and make sure they're covered in your papers, in your posters, in your bench scale, etc. So with that, that's an overview. Let me just ask if there's any questions. Okay, any questions right now because Dan's going to go into elements of what to expect on what you're going to see when people give a presentation. What's the paper need to look like? What should the poster look like? What times do you have? How much time do you have? When you should start putting your evaluations together and start your projects. So, but as an overview, what I just talked about, the difference between this being a science and engineering contest, not a science fair project. Anybody have any questions for me on any of the teams that are on? Okay. If not, then I'm going to hand it over to Dan and let him kind of go into some more detail on each elements of the design contest.
Thanks, Mike. I thought maybe before going any further, it might be useful for you folks to know a little bit about us. You know, like what is my connection background to this contest? Why am I somebody they asked to come over here and talk to you this morning? And Mike, maybe the same way. As I understand, you've been basically an advisor and a judge for almost the entire life of the contest, which is almost 30 years now.
Yeah, 28 years, 27 years, something like that.
I've done everything, and it's all just been kind of by accident. I was a professor at Ohio University in Athens, Ohio, in the chemical engineering department, and our department began sending teams to this contest in 1999. I got involved in 2000 for that contest, and every year up through 2012, I was part of the advising team for anywhere from 1 to 4 teams that were sent by our school to this contest. I retired from Ohio U in 2012, and for about a half a dozen reasons, only one of which having to do with this contest, retired to southern New Mexico, mostly because of family reasons. And then I became involved in the contest as an employee of it. So I kind of went to the dark side, as the others might have said, and served as a staff member, usually in the safety aspects. But then the last 2 years, I've been asked to serve as a judge, This year, I'm going to go back to being an employee and help with the sample preparations and so forth. So I've done a little bit of everything over almost the last 20 years. So anyway, just though you might want to know where I'm coming from here. So just going on. So I kind of look at this as the way the students always do. What do I have to do to win? And there are several components, as I just passed on that slide. The first one, of course, is before you do anything else, you need to look at what the tasks, as they're called, the projects or the problems, and choose one or more that you would want to involve yourself in, that you think you might have student interest in. Some of them seem to be geared. We, as a chemical engineering department person, we tended to look for ones that involved chemical engineering things, a separations process or a reactions process or something. But other engineering disciplines might look for one of the others. There's some here that deal with photovoltaics and so forth. So you find something that's interesting. Many schools use, or I don't know many, but some use this as a senior design project for their senior design class, whatever, in their electrical, chemical, civil engineering curriculum. We never did that, primarily because of logistics with regard to timing. We always did this as a technical elective for the students. So they would have an incentive to actually do well. They would receive a grade at the end. And they would get something, it would be part of their course load, so they would not be trying to do this as an extracurricular activity on top of all of the other activities they have to do as seniors or juniors. We would actually let any year do it, even freshmen if they really were gung-ho about it. So that's how. So you first would look at the tasks. You want to pick something that of interest, that the students would be excited about, possibly learning something about, and providing a solution. These are generally really open problems. They don't have a solution out there somewhere that they're expecting you to find. They don't know what the solution is. Otherwise, they wouldn't propose, they being the sponsors, wouldn't propose the task. So there is no answer here, correct answer. There could be lots of answers, and that's part of the whole point of this. Go out, try to solve a real world problem or come up with a solution, a possible solution to a real world problem. And the other question the students always want to know the answer to, and everybody does, is how do I win? How do I get my first place award here? And this takes us to what are the facets of the contest? What are the parts that are scored, that are graded, that you have to provide and do well on in order to get the highest score and be first place or second place or whatever? There are 4 components, as has been alluded to. The most important as far as impact and number of points is the paper. I've been told by judges that they know who the winner is going to be before they ever get to Las Cruces because of the quality of the paper, because that sets their mind. I don't know if this is really true, but I was told that once. And that really brought home the importance of a good quality paper, because the judges will see that before they ever see you in person. It's due about 2 weeks before the contest starts. The judges will have read it and already scored it, likely before the contest starts, and they'll have formed an opinion about your team, about your effort, and what to expect when they see you in person. And so you want to have that be a good opinion. And so you want to write a good paper, and that means every aspect of it. English, grammar, spelling, punctuation, it's all important. It's important that the paper read as though it was written by one person, even though it might have 5 different authors, each doing a different section. There are aspects of the paper that are required in addition to the technical aspect. Most of the time, the teams seem to think, well, as Mike said, it's the technical part that's most important. What's our results? But there are actually several other aspects to the paper: the business and economic plan, the environmental or health and safety plan, and the legal and regulatory issues. And those have to be part of the paper, not a large part of the paper, but a significant enough part that you have shown that you've addressed it. And a kind of a rule of thumb that we always used was, given that the paper, I think, is limited to 25 pages or something, or 26, something like that, 20% of it would be devoted to those non-technical issues. So maybe 20 pages to get everything that you need in there: the introduction, the investigation of alternative technologies, the approach you took, the results you obtained, the significance, and then you have 5 pages to talk about the business plan. And there needs to be one. You need to talk about the costs, how you're going to earn back if you're going to form a company to do this, how you're going to make a profit, startup costs of materials and so forth. You're going to talk about the legal and regulatory environment and the issues you have to face there. But they don't want to be half the paper or 2/3 of the paper. But they need to be there. 1.5 to 2 pages each was our general thought on that as we would ask the students, or the students would write the papers. As it says up there, pay attention to the audits. That's something that sometimes gets treated with kind of a short shrift. The idea is that you show your paper once it's complete to experts in those fields of legal, regulatory, business, and environmental or health and safety, and get their comments and incorporate those comments in the paper and show that you've actually evaluated them. Sometimes we would get comments when I was an advisor. We would get comments and we would observe them and say, okay, well, we don't think that that's important enough, and we would acknowledge that we got the comment, but we would also say that we didn't change the paper as a result of it. But that was rare. It was more common that, yes, we received these comments from John Smith at this company, and we incorporated them in this section of the paper. But so you want to find people, and this is often a question: who do I get to audit? Well, if you're looking for someone to audit the business plan, typically universities will have a business school or a department of economics or somebody. Find a professor there or somebody who's, if you have a business incubator like they have here in New Mexico State, the Arrowhead Center, there's people there whose jobs are all day long writing business plans. Have one of them, if they'll agree to read that for you and provide some comments on your plans. Most universities have an environmental health and safety office, and there's somebody there who is usually an expert in regulatory issues and EPA regulations and things like that, and they'll be glad to read the paper in our experience. And so that's what you want to look for, people like that. You want to kind of give them a heads up that the paper is going to be coming, and they've got a week, maybe 2 at most, to get back with you because you're on a deadline as far as getting your paper submitted. And as I say at the bottom there's always the problem of feeling like, geez, if I just wrote this myself, it would come out better than if I let the students keep going back and forth. Well, you didn't get this, but you really have to kind of let them do the job. They are seniors mostly, sometimes juniors, but they're seniors. They're, literally 5 minutes away from graduating and going out into the world and start working where they're really going to be writing all the time. And so they should be getting ready for it and be fairly well prepared for it.
Can I just add a couple
Sure.
things? So the design contest, the scoring includes four major topics: the paper, your presentation, the bench scale, and the poster. And those are not weighted equally. The paper is weighted a little bit higher, as Dan mentioned. So it is important to do a good paper. And part of the reason that there's 2 reasons that it's weighted a little bit higher. One is, in engineering and science, we often don't write well, and we need to learn how to write because putting out submittals to proposals is going to be important in the real world. Learning to write better is important. But the second reason is that under most RFP processes that you see in industry, you have to submit the paper in the first, and if that's not well done, they never ask you to come back and you don't go any further. So we always have thought with the design contest that trying to get students to provide technical information in an intelligent way, well done, is going to serve them well in their careers, because writing reasonable papers that are accurate, that have the right punctuation, that look well done, provides a company an opportunity to say, yes, we want to bring this group in to go the next step. So it really is what drives you in most of these RFP processes to get to the next step, is to have a good paper. This design contest, it's the same way. We've got a little bit higher scoring on the paper. You've got a little extra time to do that. It's not, sometimes some schools have difficulty with benches and things like that because of the costs of some of the demonstrations needed to show the process. But the paper can always be done well. It's easy for all the students and the teams to do a good paper. So that has a little more weight than the other three elements. So Dan's right. This is important. Really work on it and make sure that this is done right. And when the contest says address these things in your paper, make sure each one of those is addressed. The audits, the health and safety, the costs, etc. So.
Okay. Any questions on the paper?
Okay. I just wanted to also mention once again, talking about experience, when we first started doing this contest, we didn't pay a lot of attention to the paper.
I know.
You read some of them. We would let the students write them. They would be scrambling to get it done like 10 minutes before we had to fax it to Las Cruces. And we were told on more than one occasion, your team would have probably won an award because you had a good idea, but your paper wasn't very good.
That is true.
And so that was, we had to learn it.
Dan, can you explain why you put that pilot study?
Oh, that's just the name of a recent paper.
That's an example.
Example of the paper title, just to give some visuals to the slide. You know how it is.
So it gives you an idea of
What-
of an open task project that was done by a team last year.
Yep.
Okay.
Okay. One of the activities when you come to Las Cruces will be to make an oral presentation. I don't have any photos of an actual in-progress oral presentation, but the students typically dress nicely. It's a half an hour time slot allotted. They run through the course of the day on the first full day on Monday of the contest week. You get, I think it's 15 minutes and then a 10-minute, or something like that, 15 or 20 minutes, and then a period for questions, and then like a 5-minute changeover at the end of the half hour to the next team. And as I say here, you do want to be good at it. You want to be polished. You don't want to read from cue cards. There were some teams that have done that. It tends to detract from the quality of or from the overall experience. You want to get the timing right. You want to finish a minute or two maybe before the time is up. You can't run long. You'll be stopped. And if you stop halfway through the time period you're allowed, people will wonder why you didn't take more time. Faculty advisors, the rules have changed over the years, whether or not the faculty advisor can sit in on the presentation. I'm a firm believer in the Heisenberg uncertainty principle here, and that is that the presence of the advisor changes the talk because the students are, whereas if they're on their own in there, there's a different atmosphere. But anyway, if you're allowed to be there, you're allowed to sit in the corner quietly. And so that's it. That's part of the overall effort that you're going to do. And I don't really have much more to say on that. It's a technical presentation, but you are going to cover all the aspects. And one last comment, it's usually reasonable to have, again, I don't know if the rules have changed over the years, but sometimes there was a limit to only 4 of the team members could talk. They all could be in the room. It may vary, but you do want to let different students talk. You don't want to have the whole talk done by one student.
Let me just tell you why we have the oral presentations in here. Really 2 reasons. One is that if your paper's good in a real RFP process, you're going to get asked to come in and present your ideas to a company, to a technical review committee. It happens all the time. And we know that in engineering, that's something that we generally do not focus on, which is communication and interaction. And we thought that is a very big element in your future over the course of your career. And so we wanted to try and break that ice and get these teams used to the fact that standing up in front of an audience, in front of technical people, presenting your work, answering questions is good for you. It's good for the teams. And the fact that you will practice this 4 or 5 times is good, because you'll probably have 10 times more experience than anybody else in your college after this design contest, and being able to present in front of people and understand how they ask questions, the type of questions they ask. The more you do it, the better off you're going to be in the future. So this is a real part of the real world. this is an opportunity to help you guys get more proficient at that. It's just like the paper. Writing the paper isn't something you'll be doing a lot of in the future, and we want you to get a chance to get experience in that. So it is important. They will ask you good questions. They're not trying to trick you. You'll find that many of these judges have 30 years of experience, and they know how to get directly to a critical question that you will say, oh my God, I wish we'd thought about that. That's a great question. But anyway, it's for your benefit to get some experience, and it's important in the real world in the sense that you can't really move forward if you give a very bad oral presentation on some of these projects and RFPs. They won't, you won't get accepted. So this is an important aspect as you move forward in your careers. So.
And I just think one other quick comment that we always tell students, I don't know is an answer to a question. It's a good answer. And the advantage here is that if you're asked a question and you don't have the answer in front of you, you have time because you'll see the judges again the next day when they visit your bench, and you have time to go and get an answer to that question and provide it. And it's much better to say, we don't know that, we'll get an answer and get back with you within 24 hours or something, than to tend to start BSing, because that will come out in 2 seconds. So, all right, let's go on here. As has been mentioned, in addition to the oral presentation in the paper, you're going to prepare a demonstration, an actual bench scale, so that, as opposed to pilot scale, it's a small demonstration. Sometimes it's done outside, depending on whether the space is needed or whether we need ventilation or sunlight sometimes. But it's on a table, like I don't know, little
like you see here.
Like you see here. And so you want to demonstrate your process. You want to actually treat your sample if your task requires that. As I tried to say in that first bullet there, your technology has to work, obviously, but definitely it can vary depending on the particular task and the technology, whether you can accomplish it in 30 minutes. So you're going to have from Monday through Tuesday to actually treat your sample. You may or may not be able to actually demonstrate the full process in the 30 minutes the judges are visiting. But if you've ever seen a cooking show where they put the batter together and then shove it in the oven, and then 2 seconds later they pull out a baked cake, they're showing you the steps along the way. And we've seen many instances of that as judges, where the students will prepare, well, this is what the samples look like when they go in. This is what they look like when this stage. This is what they look like there. And this is what they look like when they come out. So they're sort of pre-done, especially if it's a process that takes 3 or 4 hours to run or overnight to run, and they can't do it in a half an hour. So you want to demonstrate your technology, obviously, when you accomplish the task, but you want to try to demonstrate it as much as you can in front of the judges, or at least show what happens along the way. It's important, obviously, you're going to get hit with this 100 times, is keeping your bench area neat, observe safety requirements. There are rules regarding wearing safety, protect the PPE, and who can go behind the bench and so forth. Again, like the talk, divide the presentation up amongst the students. Let everybody have a chance to say something, or most everybody. When I say that, okay, we're going to talk about team sizes in a minute, but teams have ranged all the way, in my experience, from 3 people to 25 for one task. Depending, I always wondered how the team could function with that many people. Now, obviously, if you have a team of 15 or 20 people, you're not all going to talk in 20 minutes. But the point is, try to spread it around as you can. And the poster is the other aspect of the the other of the 4 areas that you have to prepare something and present. And it kind of goes along with the bench scale demonstration. You're going to have it on an easel right next to your bench. I've got a couple of examples there. Most people are familiar with a poster they prepared for a AICHE conference or something like that. And it's similar to that. You want to avoid being too wordy, but you also want to avoid being too picture-y. You kind of want to find the right middle. And you want to have the poster be part of the discussion. You can often point. Students can point to parts of which may show a photograph or something like that, or a scanning electron microscope image or something that they don't have in front of them otherwise, so they can make a nice combination of paper and poster. There is a size limit. I think it's 4 foot by 4 foot is the maximum it can be. And again, it's all part of what you have to prepare when you want to come out here. Any comments?
I just was going to follow up. The reason that we added the poster is it's very common in the technical field to have poster sessions at technical meetings. And in a poster session, you're kind of, you'll see the judges again. You'll have already seen them once. You'll see them a second time. You'll be more familiar with them often. But in these posters and in the real world, you'll have the public coming by. And so you'll have to you may end up giving a presentation to 1 or 2 sets of judges, but you may have 10 or 15 people from the public come by and ask you about your process. They see your bench. They're interested in what your topic is. And you have to be able to kind of talk to the public, talk to people that aren't technical. And so this gives you an opportunity to get experience dealing with the public, dealing with judges on a little bit less structured basis than in a presentation. It also gives you a chance if you have 4 or 5 members of your team and you pick 2 or so to give the presentation, or 3, here's an opportunity for the other 2 to talk to the judges and work on their skills in communicating with the public, etc. So it gives you a chance to kind of optimize how you utilize your team members, how you best present, but it continues to give you opportunities to interact with a lot of the public. And what we see oftentimes with the poster and the benches is judges will be on a task and they're going, I really am interested in that photovoltaic task. And then after they're done judging, they'll go over and talk to the other teams and ask them questions as if, not as a judge, but as a public interest. And they're interested in this. So you'll see a lot of public and judges, when they're finished judging, come over and talk to different teams. This is something that you'll see in all of the professional societies have poster sessions. You'll have opportunities to present at a number of conferences in your career if you chose to go that route. So.
And I had a comment from students who participated last year, and they said that they really loved the bench scale demonstration. They liked talking to the judges and felt like the judges treated them more as peers rather than they were coming to judge them.
Right.
And so the students really enjoyed that bench scale demonstration. And I understand that there are teams of judges, at least 4 judges per team?
Yeah,
anywhere from 3 to 4 judges at a time.
I was going to say the scheduling on that is that you get one oral presentation. So you'll present to all of the judges on judging your task, which could be 10 or 12. And then over the course of the Tuesday, the bench scale day, you'll get visited by subsets of those. You probably have to make your presentation 3 times, maybe at 9 to 10, 9:30, 10:30 to 11, and 1:30 to 2 or something like that. Over the course of the day to different subsets of the judges that are judging your task. So you'll get several opportunities to say it. And then as Mike was saying, anybody could stop by. The dean of the college here could stop by. The president of the university could drop in and say hello and visit a couple of tasks. Certainly members of the media will be here. The university's own press office as well as local media could be here. So there's always, and that sometimes they would bring, grade schools would bring a field trip in or something. I don't know if they still do that, but it's anybody could come and talk or come and see your proposal and your bench, and you'll have opportunities to talk to all walks of life. Okay.
Any questions on that?
We're doing really well. Okay. All right. I just wanted to bring up some issues to consider here. We get asked this sometimes, or a lot of the time. Do we need to have these or those, or what kind of background amongst the students on the team? In my experience as an advisor, we almost always had nothing but chemical engineers being chemical engineering faculty and being familiar with the students in those departments. We would get sometimes civil or mechanical engineering students. Once in a while, we could get somebody from one of those departments to act as an advisor. But all kinds of teams have been successful. Teams that have a mix of majors, teams that have all one major, teams that bring in non-engineering people like a business major or even an art major to help with the design of the poster. If you have that, great. If you don't have that, you can learn it, okay? Engineers all have to do a senior design project that all involves an economic analysis of whatever they're designing. So even if you don't have a business major on your team, you can still write a business plan, okay? So I just wanted to make that point there. Get your people together, and if you're interested, they can make it work. As I say at the last bullet there, we often, if there were students outside our department, it was often because they had a friend in that other department that was interested in doing it, and if we could get permission from their advisor or something to take some time to work on this, that would be that would be no problem. So we would have all kinds of teams.
So I wanted to just mention that we've had in the past a number of schools that are science schools, not engineering schools. And some of the projects that we get each year could be addressed by schools that have science programs and not engineering programs. And they have done very well in the past. Matter of fact, one of the science schools won first prize in first place in one of the tasks. You don't have to have any engineering students on your group if you want, but if it's a science-like project and you can get a business person or that can help you with the economics, you can address a number of these things without having to have engineering on there. A lot of teams, though, will look at a business person or a health and safety person to try to help them out in some of those areas that many groups don't have specific curriculum to handle that. But you don't have to have straight engineers. You can have a mixture of business and science and still do well in this contest. We've had schools that have done that.
I didn't want my comments to scare off the.
But, and whatever you do is don't have all chemical engineers, because that's really a bad. No,
I would agree with that.
If you want to have all civil engineers, that's okay, but then you don't want all chemical engineers.
Any questions on that?
Nope.
Okay, how much does it cost? Well, I put up what we used to spend. I'm guessing my university still sends teams out here. It depends on the airfares, or, we would always fly out from Columbus, Ohio. It was far enough away that it wasn't really practical to drive. But teams have driven here from Canada. I think the University of Manitoba drove down here, and from Montana State. They pack up a couple of vans and drive down.
Michigan Tech has been here and driven.
I remember, as I recall, the University of Arkansas, which has been a common attendee here, will often bring their entire bench scale set up in the back of a couple of pickup trucks. So they'll all just hop onto a couple of university pickup trucks and drive from Arkansas over here. So you have to obviously be prepared for the cost of getting here, the cost of hotels while you're here, meals and such, as you would traveling to any conference. And then you have to obviously have money to spend for the actual technology. You're going to be examining technologies, picking one to demonstrate. You're going to have to buy chemicals, apparatus probably. We would scrounge whatever we could around campus, and we could often scrounge quite a bit. When the university's been around for 200 years, you can find some really old stuff there. But there's going to be a cost. And we would start sort of tentatively budget $1,000 per task team. Okay, you got $1,000 to spend. I mean, you could spend $300 on chemicals alone. And if you need a centrifuge or something, I don't know what. And then if there was going to be more money, we would go to the department chair with our hands out, or look for additional funding. And surprisingly, we could get quite a bit from, maybe it wasn't a surprise, from campus sources. There are undergraduate research funds and so forth. The internal pots of money you can go for. The college will sometimes have funds that can be used for undergraduate research. Corporate sponsors, as I mentioned there, we had a student whose mother worked for Chrysler, and she knew who to get in touch with where they would support this sort of thing. We also had, being in Ohio, we had several students who's had family members work for Procter & Gamble in Cincinnati, and so that's just some examples. There's all kinds of possibilities for finding funding sources. But yes, it does cost money to come and to do this. But it's a wonderful experience, and it impresses me year after year that teams can bring, the schools can bring 4 teams of 6 or 7 students each year after year. I think what happens, I'm hoping, is that the school, especially the college, sees the success of this and diverts money for it. So, success begets success. So, yes.
So let's see, I had one little comment on that, and that is what I have experienced from most of the schools that come, they'll spend $500 to $1,000 on their bench scale task. Something in some cases it's a little bit more, can be a little bit less. Then they spend money, for students to a hotel room for a couple of 4 nights or so. A lot of the food, though, when they get here is covered by WERC. So they have lunches, they have dinners, they have banquets. So most of that is covered when you get here. But the transportation can be difficult. If you have a little bit of a smaller team, a lot of people will get a university van and drive it down. And therefore, it's not that expensive. You don't have to rent the vans. Some of the teams find out, though, that if they're bigger teams, that just getting airfare is better than it is taking the liability of driving. So we've had people, I know Michigan Tech has driven down before, Montana Tech. We've had groups from Delahousie in Canada that drove down, and we've had teams that have flown in. I know we had a team from MIT, just 2 people, and they drove down to New York City and got direct flight from New York to Albuquerque and rented a car and came down with their stuff. So there's with some really inexpensive one, JetBlue, flying that way. So you just have to check that out. The hotel rooms are not that expensive in Las Cruces. About $90 to $100 a night is what you can get here.
Some in the
some more,
70s.
Some in the 70s.
And there's a Motel 6 here that still charges only $6. No.
And there's several hotels right next to the campus. So you're walk across it's a major boulevard, but we're talking about walking across a football field or so to get to the campus. So you don't have to be that far away. So it can be inexpensive. It can also be very expensive depending upon how many people that you want to bring. I will tell you that talking to the university, colleges that you deal with, a lot of times they have funds to support some of these types of extracurricular activities. And there are oftentimes environmental groups in your communities that are familiar with this design contest that have volunteered. $2,000 and $3,000 is not a big sum of money for a lot of companies to volunteer for this. And with that, 1 or 2 companies is all you really need oftentimes to get to come to the contest. So that's.
I just want to make a couple other comments. You notice my picture there is welcome to Phoenix. My point there is that don't look only at flights to El Paso, because El Paso tends to be kind of a secondary airport almost. As Mike mentioned, you can fly into Albuquerque, which is a bigger airport and has better connections across the country, and it's a 3-hour ride from there to here versus an hour from El Paso. It's not an outrageous drive, And we often did that. In fact, in the 12 years that I did this, I think we flew into El Paso once. Most of the time it was to Albuquerque, because you could get a direct flight from Columbus, Ohio, a nonstop to Albuquerque, instead of having to hop in a couple of other cities on the way. And it could often be cheaper. And since it costs the same to rent, once you get here, you're going to need a vehicle. So whether you fly to El Paso or fly to Albuquerque, you're going to need a van typically, and it costs the same to rent it from El Paso as to Albuquerque, and it doesn't usually get unlimited mileage. And if you've got unlimited mileage and you got some time, you can drive down. So I'm saying, look around Tucson. We even did fly into Phoenix a couple times because we tended to be generous faculty, and we would go visit the Grand Canyon before going home. If you had interest in how all that worked, let me know. But my point here is that look around. You can fly into places other than El Paso. And I want to mention the shipping. I think I'm going to mention this later, but you're going to want to ship stuff out here, but you're going to want to be careful what you ship. I think I'll get to that in a later slide, and if I don't, I'll remember to talk about it. But are we done?
And as far as travel and lodging, we have posted on the website information about that, the local hubs, and I'm currently working on getting room blocks at hotels for discounted rates, and that will be posted as soon as I have that done.
Any questions? Okay. Time commitment. Now, we wanted to make this point here. We've been talking about a lot of things you have to do: poster, paper, bench scale, prepare for that. It takes time to do all this. I know, as I understand, some of you are still considering whether to do this or we're going to start doing this in this winter or after the Christmas break. And I would suggest that you try to start now. Even if you are going to be more serious then, you still have a couple of months between now and mid-January. It would be reasonable to gather the students that are interested, choose tasks, do the background research, literature review, see what's been done, what are possibilities. Try to get as much done as you can, because the time goes quickly once you get back. You typically start school in the middle of January, and about a month later you want the paper ready, because you have to have time for the audits, and then you have to be able to get those audits back and get the paper and get it back to New Mexico here by I think it's the 22nd or something of March. So you need to see what your deadlines are and then back up from there as to when you need to get various things done. As I mentioned in the second bullet, I've seen this done multiple ways as an extracurricular activity where no credit at all. You just do this because it's beneficial to you as a student, or it could be a tech credit, or it could be part of a senior design course. For the faculty advisor, again, there was always a fine line between telling them what to do and letting them do it themselves and letting them trip up sometimes. We want to keep them on track. For us, that typically meant, schedule a weekly meeting. Make sure they actually make sure everybody has an action item at the end of that meeting. What are you going to do between now and next Tuesday? And make sure so that when you get done with all these things, that you arrive at the end of the term or whatever with your project ready, or your result, or your portion of your paper written. We didn't hesitate to toss off the team students who weren't living up to their commitment. That was one of the reasons we like to start early. It was kind of obvious early on. We always thought that the trip to New Mexico and whatever extracurriculars we could do was one of the incentives to doing the contest. Surprisingly, in this day and age, we would still have students that hadn't been farther west than Dayton, Ohio their whole life, or had never been on an airplane in their whole life. And so it was quite an adventure for them. Never been to the Southwest before, never been to the Grand Canyon, or even to any place out in the Southwest. So we use that as an incentive to get the students to work, and as much as the technical learning aspect of it here. Watch deadlines. And the other thing I'll make a point of here is, as an advisor, come to the contest. I see student teams that are out here where their advisor, for one reason or another, stayed home, didn't have the money, or had something else, and the students look lost. They seem abandoned. They feel like everybody else has got their advisor helping them out. And as an advisor, you're going to be a gopher when you get here. They're on the bench and you're running over to the hardware store because they need another fitting that they forgot to pack, or something like that. Or I can't tell you stories about things that break on the way out here because they weren't packed well, and you're running over to Lowe's or Home Depot or to the local beer store or beer brewing store because you can get lab equipment there, test tubes, flasks, graduated cylinders, bottle brushes, and things like that. So you want to be there. You want to be the moral support as much as anything else. So make sure you can come to the contest yourself, even if it's just for a couple of days, to see the situation, know for yourself what's happening and how it all works. All right. Any questions there? It takes time. You can't have too much time. It's like shelf space and hard disk space. You never have too much. All right. At the contest, what do you expect when you get here? It's Sunday afternoon through Wednesday night. The first official activities are around 5:30 or so on Sunday night, where you get your first free meal, a nice catered dinner. You walk through a line, they get plenty of food. They put it on your plate, not you, so they control how much you get, but you can go back for seconds and thirds. But you want to get here in the middle of the day, Sunday. One of the things you want to do first is find the stuff you got shipped out here, open up the boxes and see whether it's all there, that nothing didn't get broken or something along the way. As far as shipping, I was going to make this point earlier. Ship early enough to give it time to get here. I can tell you stories about people who thought something was going to get here Friday and it didn't show up by UPS. And so the next day it could possibly come is Monday. And so that could be at 3 p.m. on Monday when UPS does its deliveries. So they're driving to Albuquerque to pick it up there when it comes in off the airplane. Give yourself enough time for shipping. Get it here, and so it's got, ship it 2 weeks before you need to ship it rather than 1 week. They got a place here to store it, and then they'll deliver it to your bench there on Sunday. Open up the box, make sure things are okay. Begin to set up your bench scale. There's a limit to how much you can do because you won't have gotten your safety permit and been approved for operation, but you can still get your equipment set up and so forth. And then, of course, come to the dinner. There'll be a welcoming meeting, an overview, a safety briefing, and so forth. And remember to have fun. Darn it. All right. So that's what happens on Sunday. It's kind of getting to know the place, especially if you've never been here before. You want to find the facility. You want to find your hotel. You want to see where things are. So that's the Sunday events. Monday, as we've said, is the oral presentation day. The judges will typically not visit the bench scale area in any official capacity, or they won't. They may wander around just to see what's up. But that's the day that you give your oral, so you'll spend part of the day worrying about that or getting dressed up for that. They're in the same building, so you can sometimes students will run home and change and then come back to the contest, or they'll go find a bathroom and change it. I keep kicking this microphone. But that's where you start treating your sample. Especially you're going to want to know, how long does it take our process to work? 2 hours, 3 days, not 3 days, but 15 minutes. But that's where you're going to get your sample, and you're going to want to treat it. They do allow overnight operation if you let them know. You'll have to have it tended. You'll have to have 2 people there, I think is the rule. But there will be a work staffer. But I don't want to make a promise there yet. It depends on what the teams require. But it has been done, because by typically like 4 o'clock Tuesday or something like that, you have to have your sample turned in.
Right. And those of you working on the FICO remediation task, we'll work with you individually on that.
So that's Monday. You'll mostly be you'll be worried about the oral presentation and then treating your samples during the day. Tuesday is the big in the booth area day where all the judges come in and visit. So it's a very much a beehive of activity. Your student teams are presenting all day long, all over the room, and sometimes outside as well, as you can see, depending on what the task is. But so that's where you're going to be doing that. Pretty much not much more to say than that. There are some other activities. There's a reception, a networking, free ice cream thing. They do peer judging again.
Actually, we do peer judging, yes. Where the participating students go and go to bench scale demonstrations and judge those.
Yeah, other than their own or their own.
And we are
task.
adding a new facet to the competition, and that is we're calling it open mic night, and that is on Tuesday evening. We will give you a short time. We're thinking of 90 seconds to present your material as though you're presenting it to a non-technical audience. And so we're looking forward to that. That will help us meet ABET student outcome for ability to communicate with a variety of audiences.
Okay, Wednesday is kind of a quiet day. The morning is cleaning up if you haven't already. You usually need to be out of the contest area by noon. The banquet is in the late afternoon, so you have a little free time. And we suggest doing some touring if you can. Sometimes students will catch up on their schoolwork, whatever. It's a sort of a semi-free day, but then in the evening is the big banquet and the awards ceremony, and it starts around 5 o'clock and goes till 7:30 or something like that, whatever time it takes to present the awards. So that's the contest schedule. Goes quickly. Okay, this is the last slide. I did want to make a comment about shipping because we learned this as well. Don't ship things that are cheap to buy here. And I used an example. I had it up there. I don't know. Buckets. If you need buckets, you can go to Home Depot and buy a $3 bucket. But it take up a lot of room, and they weigh things, and they cost money to ship. So you want to, people have bought drills or drill bits or things like that. There's small things that don't cost that much money. It costs more to ship them here than it does to just go buy them locally, even if you don't take them home. The university loves donations. No, I don't know. But keep that in mind. Just ship what you have to. Chemicals normally are not allowed to be, the university won't take them unless they're shipped directly from the manufacturer. So if you need 100 grams of sodium hydroxide or something like that, don't buy it and have it shipped to your school and then put it in your packaging and ship it out here. Just have Fisher Scientific or whatever ship it directly here with your name on it or something like that. That's typically the way to do that. So anyway, the bottom line here, it's not common for a team to win an award its first time out. There's just so much they need to learn. I can't say it can't happen, but learn from the experience, carry it back with you. Obviously, students that don't return from one year to the next aren't going to be back to, but we do often have students who are not seniors, juniors, sometimes sophomores. We had that at Ohio, and they would see how the game was played, as they put it, and they would want to come back because now they know how to do it, they say. So if you can get underclassmen to participate, that's good for future years. As Abbas used to always say, you're already all winners just by being here. But that is true. The experience you gain, and we've had that in comments from students over the years that have come back to serve. We've had one student when I was at OU who did the contest early on, and then he went to work for Idaho National Labs or something like that. And he would do our regulatory audit every year. His job was in that area, and we were using his experience. He knew what the contest was all about. He also knew the area that we needed the auditing. We could count on him to provide the audit in a timely way and do a good job on it. So there's always benefits to the students, regardless of whether they come home with with any money, which they can't keep anyway. It goes to the school.
Not true. Not at UNM, not at University of New Mexico. It goes to students.
Does it really?
Yes.
Wow, I got to go to the University of New Mexico. We would put the winnings into the pot and use it for the following year for supporting the contest effort. So I think that's the last slide.
I always want to say one thing on the bottom line, and that is it's difficult for a first-year team or a team that hasn't been here for a year or two to win. But we've had some teams come close. And that's one of the reasons that we're having this kind of video conference today is some of the teams that have not been here in a while or are new that want to have a chance. We've kind of given you a head start. We haven't told you how to win, but we've told you how to watch out for the issues that you might not think about since this is your first time. And now you know a little bit about what to expect. You know why we have identified these issues the way we have, how to prepare for them, things that you have to be aware of. So I think now we're just trying to help you do the best job that you can do. It's kind of up to you guys on how you take this forward. So maybe we can answer any questions that you might have, general questions on any of the topics that we've covered. We've got a whole nother hour. We don't need to take it, but let's hear from you guys. Have questions. All questions right now are good questions, and that's what we're trying to do is just help you out as you move forward. Any questions by anybody? So if you're muted, you might want to turn your mute off because and then ask a question. But
Stephen, do you have anything?
But you asked me?
Yeah, do you have anything for us?
Well, I'm a little overwhelmed. Our students are definitely overwhelmed when you started hearing senior projects, since they're all community college students. So I'm going to have to talk them back down off the ledge. I don't really have too many. It's more just, if I could, it would be nice if you could send me a couple of the previous sort of papers so that my students can get familiar with the format and how to do that kind of stuff.
I think there is one. There is one sort of example paper on the WERC website.
Oh, that's great.
Yeah, I believe there is.
I will send you, I'll help you locate that on the website.
Okay.
And can send others if you need that too. So that would be no problem.
I'll be in touch with you, I'm sure, many times.
Yes.
Okay.
If you want my email address or Mike's email address, I don't know. I can write it on this piece of paper and hold it up. It's just my last name, Gulino @nmsu.edu.
I'll be down there tomorrow learning about how to grow hemp. So.
Oh, okay.
And David from OSU, are you there with us? He's logged in, but we're not hearing from him.
Okay.
And Billy, did you have any
Hello.
questions for us? Yes.
Can you hear me?
Yes. And where are you from?
Albuquerque.
Ah, very good.
Yes.
Did you have any questions?
No questions. I guess everything will be on the website, and it was pretty nice work you guys presented, and presented a lot of issues and how to win and what to expect. And some of those questions I had was most of them that you guys already covered already. And
Okay.
so yeah. So
all right. No.
Just,
Thank you for attending.
You're welcome. I'll be hearing more from you guys later on, and we'll be sending emails to each other, and if we have personal questions or something that we need to ask, we'll contact you guys.
Okay.
Very good. Thank you. And very good. Thank you. And Professor Lampert, are you there?
Maybe his microphone's not working.
Yeah.
It's been a while. He probably walked away or something. Just ask.
I don't know. Maybe some of them might have been watching it on their computers, and some don't have microphones attached.
Yeah,
That could be.
Yeah.
That could be.
Okay.
There's a chat feature.
Well,
if you have questions too.
Oh, there is a chat feature if you'd like to chat your questions. And also, please feel free to send me email anytime at, let's see, WERC@nmsu.edu is the email address.
Okay.
Okay. It
All
looks like.
Thank you.
And Dan wanted to mention, for those of you who live where it's cold, that coming here in April
is what makes you want to move here.
The
weather is perfect. That's why they hold it in April. No.
All right. Thank you all for attending. We really appreciate it. And please let me know if you have any other questions.
Thank you.
Thank you.